students, myself Tariq Nadeem, I am a physics teacher. So in this particular class, we'll discuss an important topic of class 10th physics, that's Ohm's law. So I'll give the title of my today's class, that is Ohm's law. So dear students, so far we have discussed some important topics of this unit, that is electric current and potential difference. And we know that electric current is actually the flow of charges, and these charges are actually electrons. All right. So I'll repeat this. This electric current is the flow of charge. All right. And we know that this potential difference causes these charges to flow. So potential difference causes these charges to flow. Potential difference causes these charges to flow. To flow in a particular direction. When we talk about this dielectric current, so here the question arises: if this potential difference causes these charges to flow, arises this electric current, so what is the dependence of this potential difference on this electric current? How this potential difference affects our electric current? How these two are related with each other? So it was actually Ohm, George Simon Ohm, who put forward his views, who put forward his law to explain, to discuss the relationship between potential difference and electric current. So I'll write the law of Ohm, that's Ohm's law, in this way. It was actually Ohm, George Simon Ohm, who gave the relationship between this potential difference and this electric current, and use his law in this way. According to Ohm's law, so I will write here, according to Ohm's law, the electric current flowing through a conductor is directly proportional to the potential difference applied across the ends of the conductor. But this law is only variable when we provide some physical conditions. We must apply some physical conditions. These physical conditions must be same, and these physical conditions are our temperature must be same, at same temperature must be same. So this law comes true. All right, and there are some other physical conditions. Here we'll discuss this temperature is important parameter here, which should be excluded from this concept, from this law. All right. So from this law we can write this in a mathematical form, and that mathematical form we have, that is, this I is proportional to V, and we know that V is our potential difference and this I is our electric current. So there is a proportionality. These two are directly proportional to each other according to the Ohm's law. So we can also write this V is proportional to I. So in order to write this proportionality in the equation form, we must put some proportionality constant here, and we can write this V is equal to IR, and this R here is our proportionality constant. And this proportionality constant is known as the resistance. A resistance. All right? And this resistance, this proportional constant is affected by its own parameters. This is not affected by this voltage or this current in this relation. This resistance depends upon its own physical parameters. That is, this R depends upon temperature, material, length of the conductor, and area of cross section. So this relation can be also write in the form. We can also write this equation in the form. We know V is equal to IR, and we can also write this equation in the form, that is V divided by I is equal to R. And this R is actually constant. The materials which maintain this R as constant, maintain this constant. That means their ratio V by I always comes out to be constant. We call these materials as ohmic materials. Alright? So this relation can also be written in this form. We can write this V divided by R is equal to I. So this relation shows us that this V is proportional to I, and this I is inversely proportional to this resistance. Alright? That means with increase in potential difference, there is increase in electric current as well. And also with increase in resistance of a conductor, we'll find this our current decreases at the same rate. Alright? So this R is inversely proportional to I, and this V is proportional to I. Alright? So this R, we know that its unit is ohm. This R is equal to V divided by I. When V is equal to 1 volt and this I is equal to 1 ampere current. Alright, we can say our resistance R is equal to 1 ohm. Alright, so the SI unit of this resistance is ohm, right? So if we draw a plot between this voltage V and current I, we find such a kind of graph. Let's say this is our current I, and this is our voltage V. When we talk about this ohmic materials, when we talk about this Ohm's law, we find a straight line graph between this I and V, and this line is actually the ratio of V and I, and this comes out to be a straight line graph. Straight line graph. And this shows that the relationship between, this shows that there is a linear relationship between current and potential difference. Alright? So, dear students, till now we discussed some important things regarding this Ohm's law. First, we understand what is Ohm's law, and then we see this Ohm's law relates the potential difference and electric current, and we find the relationship between this V and I, electric current, and we find the proportionality constant, that's R, and we call this as resistance. And we also know that this resistance does not depend upon V and I. This R depends upon its own physical parameters, that's the temperature of the material, the type of material, and also the length and cross section of the material. Alright, and we also find that this R is inversely proportional to this current, and this this potential difference, this current is proportional to the potential difference. So let's conclude our topic here. Thank you for watching. Thank you so much.